So we discussed some of the things that a cryptocurrency will need to achieve and what Bitcoin actually does do at the moment. But now I'm going to group them all together to make sure that step by step you understand the kind of hurdles and thought processes that Satoshi must have gone through in terms of creating their Bitcoin cryptocurrency and how blockchain comes to the rescue there. Now, some of this is really complex, so I'm going to take it step by step and then we'll land many of the big concepts. Actually, I'm going to use a simple example to help us wade out further and understand how they actually handled all of the stumbling blocks associated with cryptocurrency. So here's the example coming up. And it's to do with lending, borrowing money between mates. So let's go there. Let's say you and your mates lend and borrow money from each other all the time. You decide to record these toings and froings of funds. Initially, you decide to put them onto a document, but then you realize, of course, one person can't have that document. So then you decide to record them. Of course, it's modern times. You can put it on a web-based document so that everyone can access the document and see the transactions. That's nice. So you decide the best way to do this is to put it on an online spreadsheet, such as on Google Documents. That's nice. This spreadsheet acts as an online ledger, which, as we now know, is a record of all transactions made by all parties. So this ledger is essential in all cryptocurrencies. Let's go further. So you now all have access to the document, and you can add lines into and record any new transactions on the document. So that's cool. But then we hit our first stumbling block. Well, what's to stop someone from recording false transactions onto that online document? So you decide that the way to prevent anyone recording a false transaction is to have some form of verification. Well, that makes sense. So you introduce digital signatures. Now, this will ensure that both the sender and the recipient must agree that a transaction has actually, in fact, occurred. We decide we need some form of digital signature to ensure that both the sender and the recipient acknowledge this new transaction. So they digitally scribble their electronic moniker next to the line of the transaction. And that's nice. Except we have our second problem. Digital technology is so simple just to duplicate. So if we employed a digital signature technology such as a JPEG or a GIF file, well, how ridiculously easy would it be for any one of us just to grab it once from a document and then paste it again into a false transaction? That would be silly. Interesting idea, but we need something more. So the digital signature technology we employ will need to be intelligent in some way. It must be able to create signatures in a way that prevents it from being duplicated, like a normal JPEG file. So the signature needs to be an encrypted digital signature. Someone did that. Remember David Chaum and his blind signatures? So here's what they came back with in Bitcoin. What about a digital signature which doesn't stay static? It changes all the time, making it impossible to duplicate and reuse. Digital signatures were the second big breakthrough when it comes to achieving a currency like Bitcoin. Bitcoin utilizes encrypted digital signatures. Now, we're going to understand these maybe further on down the line on another lesson, but let's not get bogged down with the mathematics of this. But you just need to appreciate the idea that here is a digital signature that changes fluidly all the time so that it's almost impossible to definitely replicate, but even hack into. Bitcoin incorporates digital signature technology, which is so sophisticated, so complex, it means people can't replicate transactions and then pretend that they actually have more Bitcoins than they actually have. Now, just as a simple heads up to this, I'm just going to make you understand a concept. The key thing here is that the digital signature in Bitcoin doesn't remain static, but more importantly, it changes each time in line with the message. Because the digital signature in blockchain is generated as a function of the message itself. So that's an important breakthrough. Grab that thought for a second. What I'm saying is get away from the idea of a static signature that you normally use in real life. Because that thing on your license can be duplicated or just by passing it through a photocopier. In blockchain, the digital signature changes in line with the message because it is generated as a function of the message. It is generated actually by a little program, and you're going to see this more on CVs, on the CV section later on, but it's generated by a little program called a hash function generator, core within blockchain technology and Bitcoin technology. Now, I know I'm getting mathematical here, but this is the famous hash function. And what a hash function is, and you'll see this on CVs, is that it can take a message, any sort of alphanumeric message, and throw out what looks like complete gibberish. And this is known as a hash string. So a hash is a string of letters and numbers in a way that when you look at it makes no sense at all, but more importantly, you can never work back to the original message just by looking at that random number. So for example, in my SHA-256 generator, yes, I have one, if I put in Ayub paid Sally 1 Bitcoin, the signature that comes out from the hash generator will look like this. Pretty, isn't it? However, if I then put in just a minor change to the message, Ayub paid Sally 2 Bitcoins, the signature is going to look like this. Has no relation to the first signature and has no relation to seemingly anything. So there is no way you can somehow decrypt this to re-engineer and tamper with the original message or replicate this without ringing alarm bells. Now, for those of you who are twisted enough to learn more about the way digital signatures work, seek out the lesson that I've got somewhere else in the portfolio relating to digital wallets and digital signatures, probably in this course. I don't want to get bogged down. We're going to move on.